Mathematics and architecture are two fields that may seem unrelated, but they are actually intertwined. In fact, mathematics plays a crucial role in the design and construction of buildings and structures. In this video, we will explore the fascinating relationship between mathematics and architecture and how numbers are used to create beautiful and functional designs. A montage of iconic buildings and structures, such as the Eiffel Tower, the Sydney Opera House, and the Burj Khalifa. From the towering skyscrapers of modern cities to the ancient pyramids of Egypt, mathematics has been used to create some of the most impressive structures in the world. But why is math so important in architecture? A diagram of a building with various measurements and angles highlighted. Well, for starters, architecture is all about precision and accuracy. Buildings need to be designed to withstand the forces of nature, such as wind and earthquakes, and to ensure the safety of the people who use them. This requires careful calculations and measurements, which are based on mathematical principles. A time-lapse of an architect sketching a building design on paper. But it's not just about safety. Mathematics also plays a key role in creating aesthetically pleasing designs. Architects use mathematical concepts such as symmetry, proportion, and geometry to create visually appealing structures that are pleasing to the eye. A series of images showing the use of symmetry, proportion, and geometry in building designs. So, whether you realize it or not, mathematics is all around us, even in the buildings we inhabit. In the next segment, we will explore how architects use math to create structures that are both functional and beautiful. One of the most famous mathematical concepts used in architecture is the golden ratio. This is a mathematical ratio that is found in nature and has been used by architects for centuries to create harmonious and balanced designs. A diagram of the golden ratio spiral and examples of its use in architecture, such as the Parthenon in Greece and the Notre Dame Cathedral in France. The golden ratio is a ratio of approximately 1.618 to 1, and it is found in many natural phenomena, such as the spiral patterns of seashells and the branching patterns of trees. In architecture, it is used to create pleasing proportions and balance in building designs. An architect using the golden ratio to design a building, with measurements and calculations shown on screen. Architects use the golden ratio to determine the proportions of various elements in a building, such as the height and width of columns, the spacing between windows, and the placement of decorative features. By using this ratio, they can create designs that are visually appealing and harmonious. Examples of buildings that use the golden ratio, such as the Guggenheim Museum in New York and the Villa Savoye in France. The golden ratio is just one example of how mathematics is used in architecture to create beautiful and functional design. In the next segment, we will explore another mathematical concept that is essential to the design of buildings: geometry. Geometry is another mathematical concept that is essential to the design of buildings. In fact, geometry has been used in architecture since ancient times, with examples such as the pyramids of Egypt and the temples of Greece. Examples of buildings that use geometry, such as the Taj Mahal in India and the Sagrada Familia in Spain. Geometry is used in architecture to create shapes and forms that are both functional and aesthetically pleasing. Architects use geometric shapes such as circles, squares, and triangles to create patterns and designs that are visually appealing. An architect using geometric shapes to design a building, with measurements and calculations shown on screen. But it's not just about shapes. Geometry is also used to determine the angles and measurements of various elements in a building, such as the slope of a roof or the angle of a staircase. By using geometry, architects can create designs that are not only beautiful, but also functional and structurally sound. Examples of buildings that use geometry in their design, such as the Louvre Pyramid in Paris and the Walt Disney Concert Hall in Los Angeles. Geometry is a fundamental aspect of architecture, and it is used in both the design and construction of buildings. By using mathematical principles such as geometry, architects can create structures that are not only visually stunning, but also safe and functional. In the next segment, we will explore how mathematics is used in the construction of buildings. Mathematics is not only used in the design of buildings, but also in their construction. Builders and engineers use mathematical principles to ensure that buildings are constructed safely and efficiently. An engineer using mathematical calculations to determine the load-bearing capacity of a structure, and construction workers using math to measure and cut materials. One of the most important mathematical concepts used in construction is trigonometry. Trigonometry is the study of triangles and their properties, and it is used in construction to determine angles and measurements. An engineer using trigonometry to determine the angle of a roof, and construction workers using trigonometry to determine the height of a building. Trigonometry is used in construction to determine the angles of roofs, the height of buildings, and the slope of ramps and staircases. By using trigonometry, builders and engineers can ensure that buildings are constructed safely and efficiently. Examples of buildings that use trigonometry in their construction, such as the Sydney Opera House and the Burj Khalifa. Another very important mathematical concept used in construction is calculus. Calculus is used to determine the rates of change and slopes of curves, and it is used in construction to determine the optimal shape and size of structures. An engineer using calculus to determine the optimal shape of a bridge, and construction workers using calculus to determine the amount of material needed for a project. Mathematics is an essential part of the construction process, and it is used by builders and engineers to ensure that buildings are constructed safely, efficiently, and to the highest standards. In the final segment, we will explore how mathematics is used in modern architecture and the future of this fascinating field. Mathematics has been used in architecture for centuries, but it continues to play a crucial role in modern architecture. In fact, with the advent of new technologies and materials, mathematics is more important than ever in the design and construction of buildings. Examples of modern buildings that use mathematics in their design, such as the Beijing National Stadium and the CCTV headquarters in China. Architects today use advanced mathematical concepts such as fractals, topology, and algorithmic design to create innovative and complex structures that were once thought impossible. An architect using algorithmic design to create a building design, and examples of buildings that use fractals and topology in their design. Mathematics is also being used to create sustainable and environmentally friendly buildings. By using mathematical models to analyze energy consumption and optimize building design, architects can create buildings that are energy efficient and reduce their carbon footprint. Examples of sustainable buildings that use mathematical models in their design, such as the Bullitt Center in Seattle and the Pixel Building in Melbourne. As technology continues to advance, the role of mathematics in architecture will only become more important. From 3D printing to artificial intelligence, new technologies are opening up new possibilities for architects and designers. Examples of new technologies being used in architecture, such as 3D printing and virtual reality. In the future, we can expect to see even more innovative and groundbreaking designs that push the boundaries of what is possible, all thanks to the power of mathematics. A montage of futuristic building designs and new technologies being used in architecture. So, whether you are admiring the beauty of an ancient temple or marveling at the complexity of a modern skyscraper, remember that mathematics is at the heart of it all. It is the language of architecture, and it is what makes these incredible structures possible. A final shot of a beautiful building, with the words mathematics and architecture, designing with numbers displayed on the screen.